So, after wrapping up the video, I found out that Docker Desktop doesn't support the Windows Server. Sorry for the mistake. On another note, I ran into a minor issue with NAT in Azure nested VM environment. I had some trouble figuring out how to deal with NAT. If anyone has any tips on whether it's necessary to switch to L2 bridge mode, I'd love to hear your thoughts. Here's a simple picture. A Windows container is running on a Windows server. Linux is only there to send pings. Both of these computers are in the same VNet. These are the steps I took to make this video. If you are testing in your local environment, you don't need a UDL, user-defined route. The reason I used a Windows container is very simple. It's because Docker Desktop cannot route traffic to a Linux container. First, we need to switch Docker to Windows container mode. If you try to run Windows containers in Linux container mode, you will see this error message. To switch modes, right-click on the Docker icon and pick the right option. If you don't see this message, your PC might not be able to run Windows containers. If so, think about moving to the Azure environment. Let's quickly turn on hyper-v and the container feature on Windows host. Don't forget to use the admin shell when running this PowerShell command. We need to use -it option to interact with the Windows container. Without this, the container exists right away. The last part uses cmd.exe, not bash. Now we're inside the container, let's try to find the internal IP address. This should be it. Can we ping the container from the host? No problem. Secondly, we need to disable the Windows firewall. If you prefer not to, ensure that the ICMP packets are allowed to pass. Search for the active profile. Okay, this is what needs to be turned off. We can test the connectivity between the Linux machine and the Windows host. It appears to be working. However, the container is not responding. In this case, two settings need adjustment: UDL and packet forwarding. Let's start with UDL. This is important because without this configuration, ICMP packets trying to get the Docker container won't make it to the Windows host. Instead, they'll get lost somewhere in the VNet. Here's how you can define UDL in 2 easy steps. First, you need to create a route table. It's just an empty table. After you've created the table, it's time to define the actual route. Click where it says Go to Resource. Then navigate to Settings. Then Routes. Now add the route. The destination will be the IP address of the container. Since we are focusing on a single container, the mask should be 32. The next hop is the Windows host. The second step in UDL configuration is to bind the route table to the subnet. Once you've assigned the table to the subnet, the packets can reach the Windows host. But here's the thing. Even though we could ping the container from the Windows host, and we could reach the Windows host from the Linux machine, we are still missing packets. This is because the Windows host isn't forwarding packets. And now, let's turn this Windows host into a router. We are going to make a little change in the Windows registry. Enabling packet forwarding is turning 0 into 1 like this, and then reboot the machine. Please note that if you reboot the Windows host, the IP address assigned to the container should change. This requires slight adjustment to the routing configuration. This is the newly assigned IP address. Because the IP address assigned to the host is preserved, changes are only required here. We can ping the Windows host, but pinging the container still fails. However, replies are coming from the Windows host. Well, this is because the outbound traffic is netted here. Honestly, while shooting this video, I couldn't figure out how to handle NAT in the nested VM Azure environment. Please leave comments if you know how. Okay, this time I'm capturing packets on this interface to verify if packets are truly coming from the container. The sequence numbers indicate that the request and response correspond to each other. Wireshark and TCP dump show the same results. I'm looking into other ways in my next video. Thanks for watching.